Dude, Andrew makes me so mad. Oh, if Lance Sauter goes up and tries to dunk on me.
Right in balls.
Yes. Try me, I'm gonna pull a pencil out. Remember these?
No, those were markers. Expo markers.
Remember these? Dude, and they run the same play for Scanlon. So someone's getting dunked on the backside. And guess who drops it down to the backside?
You.
Me.
Wait, does Scanlon broken?
Dude, they all can.
That's what I
Pretty
said.
much.
Well,
So on this one,
Yeah.
this is one of those where they give you what the mean. I wasn't going to tell you that. What's mu stand for?
Mean.
What's sigma squared stand for?
Variance
Variance
of
of
population.
population.
Variance of the
Is that
population. Good.
That's right.
So they give you those two formulas there. And let's see if I can read all this. A daily number lottery chooses 3 balls numbered 0 through 9. The probability of winning in the lottery is 1 out of 1,000. That's just like Ohio's. Let X be the number of times you played the lottery before winning and winning the first time. Find the mean, variance, standard deviation. Interpret the results. So let's just do part A first.
Part B.
Mean, all we're going to do, this is, the probability is 1 out of 1,000. How about somebody with their calculator? Let's change that to a decimal.
0.000.
0.00.
Haha, I was right.
So the mean is going to be 1 divided by 0.001. What's that?
1,000. I guess it's 1
Then if that's, this is P, so Q would be, subtract that from 1, that'd be 0.999, right?
Yeah.
So our variance would be 0.999 divided by 0.001 squared. What's that come out to be?
999,000.
And then our standard deviation they wanted, which is just the square root of that. So what's the square root of 999,000?
999.5.
So those are those 3 things. Let's see, it says find the mean, we did all that. How many times would you expect to have to play the lottery before winning? Part B. Just looking at the probability, if your chances of winning are 1 out of 1,000, how many times would you expect to have to play before you win?
999.
Ouch.
You know you play like 3
Right.
years.
And actually,
Just buy it.
it's probably supposed to be 1,000, but let's see. I guess we could have explained this. The mean, if we were explaining this, the mean is your expected value. That's when you expect to win. So that would be 1,000. And this other stuff, variance, really no explanation for variance. But the standard deviation, that means what you're saying there is if you play 1,000 times, if we're looking at a number line, if you play 1,000 times, that's where you expect to win. Your variance or your standard deviation tells you could go back this way 999.5, which would put us back at 0.5, or we could go up this way to 1,999.5. So we expect that somewhere in this range we should win at least once. Well, no kidding, you're like going from 0 to 2,000. If you play it 2,000 times and you don't win, number one, you should probably give up. Number two, you're probably not real bright, because you probably should have gave up a long time before that.
Yeah, and you're losing money because you only won $500.
Yeah. Let's see what else. Assume that it costs $1 to play. Winners. What would you expect to make or lose? Would you expect to make or lose money playing the lottery? Well, that's pretty easy. You expect to win or lose money playing the lottery.
You're gonna lose, likely.
If you don't expect to lose, then you're your grandpa who keeps going and playing the lottery and thinking that they're going to win.
That's how my
My dad.
parents are.
Is that what your dad does too? I'm going to have to say something to George about
Oh, yeah.
George.
Stop playing
We
lottery.
could probably buy a new house.
You're the same as everybody else. All those people kill me because they come in. When I used to work at the convenience store, they'd come in and they always, oh, I just hit $500 yesterday. Yeah, but I've been working here for 15 years and you come in and spend $100 every day.
Yeah, that always takes me off. When you're just trying to buy a drink and there's some old man buying $1,000 worth of lottery tickets.
My dad,
Then he scratches them all off right there.
my dad didn't smoke and do the lottery because I had a lot of money. He's probably taking out of my college tuition.
You ain't got no college. He told me at the last game, you ain't got no college.
I probably don't. I probably don't see him. I'm probably the only one.
That's been
that's
gone a
saving
long
for
time
that.
ago.
He said, "With college tuition, that's my cigarette."
I believe it.
Other questions? I wouldn't put anything like that one on the test. There's-
For real?
No.
Those are the only ones I got questions.
Insane.
The other ones before like 23 on down, the ones before that are the ones that would actually be on the test.
Are we gonna be able to use the chart on this test?
Yeah.
We should play basketball.
And,
He needs all the shots he can get tonight.
yeah,
Facts.
you don't want to waste any of them.
You don't
Oh,
waste any baby.
you should have saw me Saturday. Saturday, I went like 1 for 10. I played terrible.
All right, if no other questions, this is what's going to be on the test. First thing. This is section 4.1, probability distributions.
And you already know since we suck, but this is still Trilogy's game of the year because they love killing trail.
Like, I did that. It's Trail and Arcane, I just love it.
Because we beat them a
But at
couple
least
years
our team
ago.
puts-
That's not going to happen again.
Yeah, we beat them. We beat them. We had our little run of beating them.
When did we beat?
Freshman and sophomore, our freshman and sophomore year.
And
Basketball?
our-
You don't
and
remember
our-
that?
And our 8th grade.
Oh, no, wait, I remember the sophomore year I was so
And
happy.
our
I was in
7th
New
grade.
York. I was skiing.
And then chanted to Cameron.
Yeah, it was like
She
one of the
don't
best
look-
I will never forget
Yeah,
that.
we lost by 9. Or we won by 9. My bad.
Yeah, they played really good that game. We should have blew them out.
What thing was that? He does want you that.
And she wanted him.
Facts.
Oh, man, he beat you.
What?
So in the first section we did probability distribution. Remember your X is what you're looking at happen. So it could be like getting 0, whatever it is, then 1, then 2, so on and so on. The frequency, really, we didn't really worry about the frequency a whole lot with this. Then you got to look at each probability. Some of the probabilities, they'll give you a chart, and you may have to add them all up and figure out, okay, there was 17 zeros out of a total of, and that's where the frequency came in, total of whatever, 200 people or something, and then you got to find that probability, so you have to write in each probability there. That's our probability distribution chart.
Yeah, I gotta go make that up.
It's pretty cool.
The
No, it was a different one.
Yeah.
We have cool videos of them.
Yeah, wait, can I show him my water night
I can
that
show.
I found?
I can show. She found this freaking.
It's actually a parasite. We looked it up. It's a parasite.
My problem was it was a Monday and I wasn't.
And I found
feeling
an
so good.
amoeba. We all found amoebas
Found that amigo where?
in zoology.
They took like water
You
out.
wanna
That's
see
what
it, Mr.
We
Ebersole?
drank that stuff?
If you
No.
go, if you
If
like,
you drink out of a
when you
lake.
swim in like a lake or like a pond or
You
something,
thought
that
that
goes
was
in
a
you.
trail, I think.
Well, yeah, I don't know.
You see that thing?
Yeah.
Yeah.
Thing's nasty, it's parasite.
Me and
That is
Michael did our
cool.
project, like our little lab over that one.
Being able to find the mean, variance, standard deviation. We use this chart to do it. You could also, and I think I have it on the next slide, but I can't say for sure. You could use this chart to find the mean, variance, and standard deviation. But we also said that you could put it into the calculator. And like I said, I think I have that on the next one. I'm hoping that I have some of these things, all the calculator stuff. If not, we'll fill them in and we'll write them in your notes there so you don't have to flip all around your notes to find the calculator stuff. But if we're doing this, this is our mean. We take x times the probability of x for each one, add them all up. That's the mean. Then we do these other parts. And this would be our variance. And once you find the variance, what do you have to do to find the standard deviation?
Square.
Just take the square root. So again, I know like CTC or Valley View, other schools I know that teach this sort of the same subject, they make everybody do these charts.
Trash.
I'd like to see you be able to do the charts, make sure that you know how to do the charts, but also if you got a calculator, then you can use it.
There's no point.
I'm gonna check this real quick just because it's bothering me and I'll turn it back.
No, writing these down, I'm probably still gonna flip through all the notes.
I thought I had this on there, but I don't. You can, using your calculator, let's write this down here. Using the calculator, now I gotta remember for sure. I know I had it on one of my PowerPoints. I must have pulled up the wrong PowerPoint.
I thought we wrote it down.
If you want to find the mean, variance, standard deviation using the calculator, I think you can put x into like list 1 and then put probability of x, the px, this column, into list 2. Looking, does anybody have it in their notes there somewhere? So you got x in list 1, probability of x in list 2, and then we do,
Stat, or no?
it's a
Okay,
stat,
go
it's,
into-
it's like second. Let me look at it here, and look at my
Yeah, it's
calculator.
P of X into L2 and then it says stat.
So then we do stat,
And then calc.
then once we do stat, we go over to calc, and we want to calculate the 1 bar, right? 1 variable stats.
And enter.
And then you do enter, and once you hit enter, it's gonna pop up. It's gonna pop, this is gonna pop up on your screen and you put in which list you use. L1, comma, L2, right? Isn't that what we did?
Yeah.
And then once you have that, then that's what we've been doing all year long, and it'll tell you the mean, it'll tell you, the standard deviation. What do you gotta do to get the variance if they ask you for the variance? Not square root, you gotta
Square it.
square it, it's like backwards, right? Might be one of those, that's been a while since we did that, so it might be one of those that you wanna look at when we do it. remember, this works, this works for any setup, but then when we got into the binomial stuff, it made it a little easier, but you could do all of this to do the binomial stuff. But you can't use this, or you can't use the binomial stuff to do every problem that fits this. So with the probability distribution, X is always your random variable. Remember, it's always discrete. Calculate, yeah, I did have it sorted on here. So if you're doing the calculator, you put in the list, remember you put in your X, and you put in your P of X, and then that'll allow you to find,
I have a question.
yep.
I can't remember how to like get into your lists.
You go to Stat and Edit.
Okay. And then
Be able to draw the histogram. Remember the histogram? With your histogram, you're just going to have your X's are going to be along this side, whatever they are. And over here is going to be your probability. Your expected value, your mean is just your expected value. That's what you expect to happen. Just like that lottery one that we were doing, we expect that we're going to have to play 1,000 times before we get a winner. That's what is expected to happen. The mean and the expected value are the same thing for probability distribution. I don't know, did you guys have all that? I went a little quick there. It's sort of the same stuff. And again, this is all section 4.1. Section 4.2 is where we switch to a binomial. All the stuff that we did in section 4.2, we could have skipped section 4.2 and just used section 4.1 to do all of that stuff. The stuff in section 4.2, if we know it's a binomial distribution, makes it a little easier to do. But not everything fits into a binomial distribution. Oh, that's the other thing too, I should have said, I forgot about that. In section 4.1, remember discrete, and everything we did this chapter was discrete, but in section 4.1, they actually had us deciding between discrete and continuous. Chapter 5 deals with continuous stuff, but remember discrete is something that we can count. So 0, 1, 2, 3, 4, 5. Continuous would be something that we can't actually count, like how much water is in the jug. Because it could be 1 ounce, it could be 2 ounces, but then it could be 2.5 ounces, could be 2.56 ounces, and so on. We didn't do a whole lot with that yet, except for deciding if something was discrete or continuous. We haven't done anything with the probabilities for continuous yet. That's next chapter. Binomial distribution. Give you a second.
course we're all going. And we're all gonna ride together too.
I'm pretty sure my dad's wearing red and blue.
My sister said this. She was like, I'm not going to be a wait. It's at your village.
So she going?
I don't know, but my mom said this to her this morning. Something about, I said, well, they're going to dump tonight. And my mom said, yeah. She said, I'm always reading someone like my money. And I said, you're reading them. She said, I'm going to feel, I know, I'm watching books.
Let's go.
I said, yeah.
You know, there's a 1 in a million chance we win.
If there's 1,000,000 times.
And
my
there's still
goal.
one. If you guys win tonight, that would be like, you all should just quit right after if you win. You're
If you
quit.
guys win.
That's like state,
No,
honestly.
no, no. If we even lose by like 10, we should just, that's successful season.
Hey, you should be successful if you lose by like, if you lose by like
20.
less than 25.
I would
Now
say-
you're getting poached.
Our problem is just scoring. We just get
Have they
scoring.
lost
Well,
any games?
that's who went, yeah, it's a really, really good team.
You lost like Mason? Or was that different team?
No,
No, they lost to Mason, who,
Is it
They
D1
lost to
school?
Cincinnati then.
yeah, Mason is D1. I mean, they're decent in D1 this year. They're not very good, but they usually are. And then we have.
I'm sure they're still good.
They're not very good, just D1.
No, they're not as good as they usually are.
The
Yeah.
Watkins, I'm sure that'll be a good game.
Hawkins is good.
Hawkins lost to Marion Louisville.
Pretty tough.
There was a fight, the one of the
Uh,
Watkins games or something, or not.
It was
coach?
Springfield and
Yeah.
some Catholic.
Oh, yeah, it was on the news.
He's on news.
Yeah.
Beautiful finish, Springfield.
Skins from socking.
Scary team.
I saw it, but I didn't read the article because I thought it was far away.
My dad was talking about the fight. Do you remember when they played at Ansonia and Ansonia slashed all the bus tires? You remember that? He was talking about that last night when they like won conference and Mike Abner got on top of the rim and was sitting on top of the rim and they cut the bus tires.
I remember something about it, but
Yeah. My dad still remembers, he goes, I remember Mark Pittman's dad, he goes, they slashed his tires on his van he used to drive and he was about to kill somebody. He was getting ready to fight the students.
They sliced it.
Yeah,
Can
they
you imagine if we did anything like that today? It would be.
In jail.
Yeah.
It would just be a joke, like,
They,
oh, we're
like,
gonna get you
won
next year.
conference or
Who
something.
did?
Trail. I think my dad's sophomore year or something. They beat Ansonia. Ansonia was good. They slashed the bus tires.
Which school was still like the old days? They had like smoke rings. Moving on to that. That was my dad's still such a hardcore smoker. He started when he was like 10.
Started down in the old elementary.
That's pretty much how it is. Vaping.
Yeah, but kids are stupid when they do it now.
There's no point.
I wouldn't like have phones or anything, stuff like that'd be so much better.
If we didn't have phones,
Yeah. Like, I mean, yeah, like a house phone.
you see a lot more people in shape.
Well, yeah, you gotta ride your bike everywhere.
You still have a car.
But not if you're not old enough.
Well, if your mom takes you.
What if she's at work, like the summer?
That'd be all day.
I'd be on that bike heading down to New Paradise.
alright, so you gotta be able to tell the difference
Bike in 30
when you can use binomial stuff, when you can't. So when you're reading these problems, one of the main things for binomial, or the main thing for a binomial, see if it can be simplified down to just two outcomes. You know, a success and a failure. That's probably the main thing that tells you, hey, I can use the binomial stuff on this. But that doesn't always tell you, it's still gotta have fixed number of trials, so like 10 trials, 50 trials, whatever. The trials all have to be independent of each other, so one can't affect the next one. And X always stands for your number of successes. That's where it's different from the Poisson or the geometric stuff. The formula is this. Again, instead of using this, you can use the calculator. With the calculator, I don't know, does anybody have it there, or do we need to write it down, or can you find it in your notes?
Binomial.
The binomial?
That was just a little video.
Yeah, I
And
don't-
second variations go down to D.
Second vars, is that right?
Yeah.
Yep,
You go to D,
yeah, and then enter. Put in P. And then comma,
enter, and you put in what?
P,
P, comma,
and then put an X,
your X,
and then close parentheses.
just close the parenthesis. It's just two of them on that one.
Wait, is this for just binomial distribution? Is this for a circle?
Binomial.
Oh,
Well,
wait,
it's
I
second
said other.
distribution, and then put an NPX, close the parenthesis, and just put
It's
N in
NP,
front of it.
yeah.
I
You
did
don't have
other,
to-
I did other
So
distribution.
is it D?
No, you go
I-
second distribution,
Wrong one.
Jen messed it all up.
I did
Second
other distribution.
distribution.
And then there's a zero in parentheses.
Okay, that's, so the zero, you go down to zero, right?
Yeah.
To zero on your
And then
calculator.
put NPX,
N, P, and X are what goes in the parentheses, right?
and then close parenthesis and enter.
Is that good enough for everybody? Does that make sense?
Yes.
So if you're on your calculator, second, oops, mine's on something stupid. Didn't want to get off. Clear, so I do second. It's second vars, right? So that part was right, second vars. And you go down till you get to zero, which is the binomial. Zero is just binom PDF. And you hit enter. And then you gotta put in N, P, and X. If you don't like that, you can use the formula.
I think that's a lot easier.
With this, again, binomial PDF is just finding one thing. Binomial CDF is finding a number and below. Number and below. So if it makes it easier, do that. I guess I had this right here, put in calculator. Be able to draw the histogram. And then the other thing with the binomial, find the mean, median, or mean, variance, and standard deviation. Those three easy formulas there, but those only work for binomials. Geometric distribution.
Who's this bit?
This is 4-3 geometric distribution. Remember, that's where we want when you're looking for your first success. So if it says something like, at what point are you going to pick the first red marble out of the bag? You're doing geometric distributions. Again, the formula, you can use the formula if you want. It's not a real difficult formula, but you can also use the calculator. For the calculator, all the keystrokes are,
Now the one, yeah.
you hit second, vars, then you go down to geometric is D, is that right?
Yeah.
That says geomet PDF,
And then enter.
and then you put in what?
P.
P and X, is that what we want?
Yes.
Just
P and X. Yeah, I guess it says it right there, I should read what I wrote. Remember, geomat PDF again is if you're doing just one number. If you're doing at and below, then you can use the CDF.
We're actually gonna have to put a box for the big game tonight.
Yeah, I'm gonna just fail. Just get crazy food. So I can't play yet.
Braden, can you read anything that you've written so far? Are you lying to me? Could anybody else read it?
They just don't lose as worse. Did we just put 40 or 30?
31.
Yeah. You know what's weird? So like at one point,
How did
you
we
guys,
put 31 going into half down by like 9?
at one point you guys were down 21, and Wyatt goes, I said, dang, we're down 20. He goes, down 21. And so I'm like, okay, that's okay. And then I'm like, dang, we're getting beat by 30. He looks at me and goes, we're down 30. I'm like, why?
I don't know. I don't know how to.
He's trying to better your math skills.
I was ready to leave after the third quarter.
I left at the third quarter.
I don't know who else is in school.
Skylar, she wouldn't be here.
You guys did?
After school. We get out after this class, when it's over.
Yeah.
We're talking like noon.
My dad always makes fun of me for that. He goes, you weren't allowed to leave early when I was in school. He goes, people dead, which weren't supposed to. But now everybody leaves after a class.
I could have. I freaking could have. But you know.
Tucson, this is 4-3 also. With Tucson's distribution, main thing with Tucson's distribution is this: successes in a certain interval. So you see them, they're saying something like within or in a certain month, or in a certain gallon of water, or in a certain whatever. If they're giving you some kind of interval in there, then you're probably using Tucson's distribution. Is this the one you guys like using the chart on?
Depends if the numbers work out.
Yeah.
Couple of them, what was the other one that the chart was fairly easy on? Was that the
That's the one we just did.
was that the geometric?
Yeah.
I can't remember what charts we actually had. No, it was the binomial one.
Yeah, binomial.
Binomial, because geometric doesn't have a chart. So binomial has a chart and Tucson has a chart. If you use a chart, that's fine if it fits the certain problem.
Either way, I'm ready to go.
Does geometric have a chart?
Yeah.
It doesn't at all.
And it's the same thing, this is a PDF is if you're doing one, CDF is if you're at or below that certain number. On your calculator, if you punch it into your calculator, second bars, which one is Tucson's?
Huh?
Is it,
It's right before the.
so it's, is it B or C, one of the two?
It's second bars go down to Tucson PDF.
It's
Is that B
it's
or
B.
B?
B is PDF and C is.
Okay, so it's, and that says Tucson PDF,
And then enter.
and then you just put in the mean and,
Comma, number of occurrences, and then enter.
so again, another thing to tell you if you're using Tucson's on a certain problem, if they give you the mean, you're probably using Tucson's distribution. So if the problem gives you mu, then you're probably using Tucson's. Just to try to help you out to make sure you know which setup you're using for each problem. A couple of things to remember. Remember, Q is just 1 minus P. Nothing hard about that. Binomials, fixed number of trials. Geo, you do till you have a success. Poisson, interval, and mean, just to help you remember which one you're dealing with.
Mr. Ebersole, if I see you at the game today, I'll be sad.
I won't be there today. My son's got a game, so.
Where they play at?
I think they're at home.
We play them here soon.
January 29th?
Is that what it is?
Sure.
I only know.
Your son might have 40 points against our JV team.
Facts.
What
He's
exercise?
horrible.
He's horrible, but I mean, look at our JV team.
He's horrible. He's gotten, the last 2 games have been better, but he's so soft. It drives me nuts. Drives me nuts. I didn't play a whole lot, but when I did play,
Soft.
I was a little scrawny kid that everybody hated because I was not soft.
I hate those kids. Cause like they're not soft, and then they got sharp elbows, so like they just come in slicing.
What?
What?
Sharp elbow?
I had roasted us, he said.
Yeah,
My
that's
class
really
sucked at
fun. That's
basketball
Coach Harrison.
compared to other classes.
Coach
He
Harrison
goes,
does this.
my
When you
class
do the
will
elbow,
kill
you, like,
our
When he
team
boxes
now.
out,
He goes, and we were not good compared to the other classes.
Bullies me.
I gotta go to the
We
post
played.
that one.
That's,
Sit on the bench. And then
I
he's
mean,
got
I
embarrassed.
was not
This
good,
is Jaden threw some people
but
around.
That's what he said. He goes, I wasn't good, but he goes, I'm pretty good. He goes, I've been pretty good compared to half those kids now.
Help
Yeah,
there,
they don't.
slid down. I'm just here.
my son thinks he's in the
And
NBA.
he- I was hoping
So
that I
you're
saw that.
way up here and stuff, and it drives me nuts. Try to
Why
tell
his son?
him, try to tell him, and
Can't miss a shot or anything.
Comes versus Trailers, 30 playing JV.
you guys didn't help, because last year in baseball, well, I guess he played pretty well against you guys.
We
last
played
year.
baseball horrible.
He hit you guys real well. That was the best he hit all year.
Wait, is that the one
Joe
we had a
Barry.
doubleheader?
He did.
Yeah,
And
He
the
did hit
freezing
some double play
cold?
ball.
And we
Did
went
he?
to that
Yeah,
at like
he hit it
8
to Camp
a.m.
in Camp Turn 2 against us. I remember that.
Scored the winning run on the one game, and
He was out. I swear he was out. Cam threw a dime to Clay, tagged him, and called him safe.
Clay never got the tag then.
That don't surprise me.
Oh my gosh.
He did the
that
same
was
thing
his
against Arcana.
Worst game
Because
ever.
I was sitting
We told
way
him,
out,
like, we're not gonna go.
But
And
you
then
could
we're
tell
gonna
he-
text each other.
and I asked my son, I said,
"Wanna go to the game?"
he goes, Daddy never even tagged me.
Yeah.
He said, he didn't even tag me after the play was over or anything. He said, he never tagged me at all.
the worst one was we was tied bottom of the 8th against Arcana, and we had more guys in the infield because they had a guy on third, 2 outs, and I was at shortstop and I backhand one. It was like a hit the hole and I backhanded. I threw a one hop to Clay because I was deep, trying just to bounce it to him. He gets down, he tries to block it. Instead of just picking it, tagging Jackson Christ out, takes it off his chest protector, bounces out, and they win. I was so mad
Oh, what game was that?
against Arcana.
Well, what I started to say is you guys didn't help any because you helped to make him soft. Because my other son played trail 4 years and he got hit 6 times. No, hold on. Because some of those games were double headers. He got hit more than that. Got hit every game, and 2 of the games he got hit twice, I think.
Was
When did
Trail
your
very
other son
good
play?
then? Was Trail good then?
They were all right.
When did your other son play?
Just a few years ago.
He
2 or
probably
3
played
years
with
ago.
Logan. Was he Logan?
No, Logan's older than him.
Like Hunter?
So it was
Or
like
no,
Bill-
He
Logan.
probably-
No, he did play with
Yeah,
Logan.
Taylor.
He did.
That's-
I'm thinking
Cause I
Taylor.
think that's the son I'm thinking of every time I think of like.
So
you
it
say
was
son.
like Billy Layman, all those guys. Because he was around the
Yeah,
same age.
he played against his last year. He played against
I think he was.
who was your guys' shortstop
The
2
one we're
years
talking
ago?
about right now.
Short
Or the
kid,
one that's
Peyton.
younger than us.
He played against Peyton one of those years because Peyton actually pitched that game and hit him.
Because Peyton never pitched.
Yeah, he looked good.
Peyton's a stud at shortstop, but he can't pitch.
On this is the review packet. Questions? You want to go through them? How do you want to do this? You want to just pick problems and work them out, or what?
Yeah.
Sure.
Let's just do-
So flip through it and look at it, and we can.
Not
30.
far apart.
Problem 30.
Chauncey Billups.
Problem 30 says, a company ships computer components in boxes that contain 100 items. Assume that the probability of a defective computer component is 0.2. Find the probability that the first defect is found in the 7th component tested. Round your answer to 4 decimal places. So the first thing, it says the first defective one is found in a certain thing. So we're using the geometric mean, or not geometric mean, geometric distribution. When we're using geometric distribution, we still need to find the P, the N,
And
the Q,
And X.
and our X, which one we want this time. So P, what's P on this one?
100. Or no. 0.2.
0.2, and I could have switched it, I switched it on you, because usually I put N first.
And then it's 100.
N's 100, Q is 0.8. And then we want it to be on which pick?
This,
7, so what's X? So X is the 7th. First defective is found, yep. And if we use the formula, you guys can get your calculators out and see if we get the same answer here. Yep.
A little bit. Now it's X7.
Because it says, what's the probability that your first defect is on the 7th one? So
Okay.
that's what we're looking for.
Okay.
So if we use the formula is going to look like this. 0.2 times 0.8, and then it's
8.2.
7 minus 1 up here. See if we get the same thing. Remember, if you use your calculator, you go second, what is it on the calculator? Second bars, go down to Geomet PDF, which is letter D. Hit enter, and you punch in, what do you put in?
0.2.
Put in P and X, right?
Yeah.
Is that right? 0.2, comma 7, close the parenthesis.
0.052.
Now if I do this, let's see if I get the same answer. 0.2 times 0.8 raised to the 6th power. I got, using the formula, I got 0.0524. Is that right?
Yeah.
So either way, whichever one you do,
So that's the answer?
that's the answer.
Okay.
So it's about a 5% chance that the first defective one you get is on the 7th one. If you wanted to see, what's the probability that let's say we're ordering 7 of them, and we want the probability that the first defective one's gonna fall within that 7, so 0 through 7, then we could just do this formula over and over again 8 times, or on our calculator, we could put in, instead of PDF, we could do CDF. So we do second bars, go down to the Geomet CDF, and we put in 0.2, comma 7, close the parenthesis, and we come up with this, 0.7903. So about 79% of the time. So if we're ordering 7 of these items, what this is telling us is about 79% of the time we're gonna get at least one that's defective. So if you know that, and you need 7 of them today, you probably don't wanna order 7. Probably wanna order 8 or 9 to get a couple extra, so that, because you know you're probably gonna have one that's defective, so that you can throw it in there and send the defective ones back. Next question. This doesn't have anything to do with the problem, but
16.
16. Problem 16. Basketball player Chauncey Billups of the Detroit Pistons makes, I probably need to update this, don't I?
And he retired.
Many years ago.
He's pretty old.
As a matter of fact, I think he was coaching somewhere, but
He is coaching.
is he?
Yeah.
Makes free throw shots at 80, does that say 88%
Yeah.
of the time? Find the probability that he misses his first shot and makes his second. So misses first, makes second. What are we using here? Are we doing Tucson, binomial, what?
If it's a make or a miss.
If it was just a make or a miss, that would just be a binomial, right?
Yeah.
But in this case, since we're looking at the fact that he makes the second one, that's his first success, we're using what again? We're using the geometric again.
So you gotta do,
So what's our n this time?
um,
Sorry, I switched
2,
here.
right?
2, because he's only shooting twice, right? So 2, we're only shooting it twice,
Then 0.88.
and the probability is 0.88. What's Q then? 0.12. Do we need all of this stuff if we're gonna use our calculator? If we're using the formula, we need all this, but if we're using our calculator, then no. What's our x this time?
um,
When do we want him to make?
second.
Second, two.
So it'll be a 2. So if we're using the or if I'm just doing the formula, it's 0.88 times 0.12 to the 2 minus 1 power. .88 times 0.12 raised to the first power. I got 0.1056.
Yep.
Yes, sir.
C.
I see you.
You do 15.
15. Let's see, 65% of men consider themselves knowledgeable football fans. If 12 men are randomly selected, find the probability that exactly 4 of them will consider themselves knowledgeable football fans. We're using binomial, geometric, or Poissons.
That'd be binomial, right?
This is just a normal binomial thing. It's either success or failure, and we have a certain number of men that we're picking. We want to know what's the probability this many say yes or no or whatever. So what's our n this time?
12.
Wait,
We pick 12. What's our p this time?
67.
67. What's our q this time?
Sorry, it's
65.
Oh, 65. What's our q this time? 4.
Or 35.
What is it?
35.
0.35. And what's our x this time?
This says exactly 4.
Exactly 4. Again, this is probably easiest on the calculator, right? I don't have the formula memorized for binomial, so you guys don't expect that I'm gonna write it up here, do you? Because that's that longer formula that sort of got crazy stuff. Not really hard, but
You put it into the list, right?
no, this one you don't have put in the list. That's only the probability distributions. What do we put in on this one?
Oh, this is the NPF.
So we hit second, bars, go down to
Binomial PDF.
binomial PDF, hit enter, and what's the three things? This time we gotta put in three things,
So
right?
12.65 and P4.
I think that's right? N, P, and X, is that what we put in?
Well, I mean, if it rounds up, it's an answer.
Oh yeah.
I do want to have some.
It you get point
You get .1989.
point 0.198.
Oh, yeah.
Point 0.1989.
And that rounds up to point 2.
So if we round that up,
Let's see.
point 019, what's, and they're rounding all the way up to point 20.
Or point 0.020.
Yeah. Which one is that?
C.
15. Okay, so they were. Wrong problem, no wonder. Yeah, alright, yeah, let's see. I was looking at 14.
Should we do number 1?
Number 1.
Just wanna make sure I'm not doing-
Wait, what did you say 16 was in?
Let's see.
I'm at 15.
15C.
State whether the variable is discrete or continuous. Remember, discrete means we can count it, 0, 1, 2, 3, 4, 5, 6, 7, 8. Continuous, so on a number line, discrete looks like this. Continuous on a number line looks like where the number line's shaded. It's considering all the fractions, decimals, and everything. The number of cups of coffee sold in the cafeteria during lunch. So if we go down here at lunch
Discrete.
and we count how many cups of coffee, is that something that we can actually count?
Yeah.
Yeah, so it's discrete.
So 2 would be continuous than the height of a player on a basketball.
Right, because player could be 6 foot, could be 6'1", could be 6'1¼ could be 6'1½", could be 6'1¾ so on and so on. Just a continuous.
5'8".
On a
What'd you
good
say?
day.
Let's do 5.
Number 5.
Number 5.
Determine the probability distribution's missing value. Remember, with a probability distribution,
Has to add up to 1.
all of them have to add up to 1, all of them have to be positives, and none of them can be higher than 1, and that sort of goes into the fact that all of them have to add up to 1, because if you have something higher than 1, then it's not going to add up to 1. 0.57, 0.07, 0.16, 0.02, and we don't know this one. So all you'd have to do here, add all these up. What's that give us?
It's 0.82.
0.82,
So then your answer's 0.18.
and then we subtract that from 1. What do you end up with?
0.18.
Which is that? Is this a multiple choice one?
Yeah, it's
Yeah.
D.
Michael was right. If he was guessing on this problem, instead of having a 25% chance of getting it right, what should he have?
1 out of 3.
1 out of 3 because
33.
B can't be right.
You just hear everything. I know, he just ignores a lot of
3 and
stuff.
4 are the same thing, right? You just add them up.
But they're actually asking you to find a probability then.
Oh, do it.
They do 3.
2, 3. So 3, this is our x. It's 0, 1. Ignore that. 2, 3, and 4. This is our frequency. And we need the probabilities out here if we were making a probability distribution. So the frequency for 0 is 125, the frequency for 1 is 428. If I write something wrong, please tell me. 256, 108, 83. We need, first thing we need that sum there unless they told us in the problem.
It's
It's 1,000. So that's 1,000. So any of these probabilities that we're finding, we'll find this first probability of it being 0. We just take 125 divided by 1,000. 428 divided by 1,000.
which is nice because it will just be that number.
Right, it just bumped the decimal over 3 places, right?
Yeah.
Let's see, which one did they ask us to find here?
Less than 2 cars.
Less than 2 cars. So we want just those 2, right?
Yeah, so you gotta add them up.
So this is 0.125, this is 0.428, and we just add those 2 to get that total.
And my 46.
0.553.
0.553. Is that one of the answers? Is this multiple choice?
Yeah, let's see. We do 6.
Number 6. On number 6, do we want to make the chart on this one? So they give us a probability distribution. 0, 1, 2, 3, 4, 0.07, 0.68, 0.21, 0.03, 0.01. All those hopefully should add up to 1. We could make this big long chart. That's what we started off doing with these. Here you're going to have x times the probability of x. Remember, when you add all those up, that's going to be your mean. Then we had x minus the mean is our next column. Then we had, you take that number and you square it. And then we take that answer, x minus the mean squared, x minus the mean squared, and we times that by the probability of each one. So we take this answer and multiply them together to get this, and we add all those up, and that gives us the variance. Once we get the variance, what do we do to find the standard deviation?
Take the square root.
Take the square root of that. So we could fill all this in. The shorter way to do it using your calculator, put this in list 1, put this in list 2, and then do the bars and all that stuff, and it'll tell you the mean and the standard deviation. This has to be 0 there. That's 0.68. Ignore that. That's 0.42. That's 0.09. That's 0.04. We add all those up.
I did.
1.1, 1.19, 1.23.
After you put it in a list, what do you go to?
You go to stat,
Stat. And then.
calculate.
Where bars stack.
Yeah, go to, so once you put it in the list, you go stat, then over to calculate and one var stats. And then you just put in your two lists. So list 1, comma, list 2.
Where are the list buttons at?
You gotta hit second, then like number 1,
Oh, I see it now.
Hey, Mr. Ebersole, can I go down there?
second, number 2, so on and so
Oh,
on.
I see it now.
And it should tell you the mean. What's the mean come out to be? 1.23.
Might take your.
Look, that's what I came with, wasn't sure. But I didn't finish it out and find the standard deviation.
What I gave me that is 0.66.
Because it starts to get a little tougher then once you get past those columns.
See you, Mr. Ebersole.
See you later. Good luck tonight. Make sure you
He's gonna
study.
need it.
Study.
So that one.
Is that one of the answers on there?
Yeah.
Yeah.
I should probably put on there that you have to use the chart, shouldn't I?
No.
So everybody does this. So we take that minus, take x minus that, it'd be negative 1.23.
Oh, the,
This minus that, so on and so on. We can do all that and square each one. Others?
25.
25.
Did you just send me the numbers?
Problem 25 says determine whether the distribution represents a probability distribution. If not, identify any requirements that are not satisfied. So looking at that we have there, is that a probability distribution? Yes or no?
No, I didn't. No. Yes.
Yes.
It's one of those two.
Yeah.
Yes?
I don't know.
Is it? Yeah.
Yes.
Yes?
Yes.
Is that what we're going with?
Yeah.
Yes.
We don't know.
Right?
I don't know. No.
No?
It's not.
It's
not.
no.
It's no.
Oh, good guess.
Yes, you
Yeah,
got it right.
50-50.
Now you gotta tell me why.
Oh, because that's a negative.
Nice
Oh.
job, Isaac.
Good, see, I didn't even see that.
Nice.
Determine.
Other questions?
Probably.
Braden, you know you're allowed to speak up back there at any point, right? You're allowed to say, hey, idiots, it's got a negative. What, say yes? Don't say that because
I might cry.
I can't have Riley crying. Or Isaac. I can't have Isaac crying.
I do get real emotional.
If I had to go call Amy and say that Isaac was crying.
Somebody called him an idiot.
That's what I call an idiot. He's crying.
He's very emotional right now.
Can you come pick him up?
Other questions?
I already gave him a pass. He's on.
24.
24.
Oh, that's a graphic, dude.
Wait, it's time can I go to the restroom?
Yeah. We have 11 minutes.
I know.
24 says in a pizza takeout restaurant, the following probability distribution was obtained. The random variable x represents the number of toppings for a large pizza. Graph the probability distribution. So this, they want us to draw a histogram. On the bottom, what numbers are we going to put on the bottom?
The 0.312 0.
0, 1, 2, 3, let's go to 4.
Yeah.
4, yeah.
What's our label down here? What's that stand for? 0, 1, 2, 3, 4.
Alright.
Toppings, right?
Top.
Number of toppings. Over on the side, what's our label going to be? That's the what?
Probably.
Probability. Probability. Looking at our probabilities here, how should I go through this, should I go like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10? What should I do on the side?
I would do it, yeah. I don't know. I
No,
don't know. It goes up to
because
point four.
0.06, 0.4. Start it. No, that'd be too much. Could you do 0.05 and just have it under?
So 0.05, that's 5%, right? Then what's the next one gonna be?
0.1.
Yeah.
Do something like that, and then 0.20, and you don't have to write in every one. 0.30, how high do we need to go?
0.4.
0.40, something like that. That works out pretty well. How high up does the 0 bar go?
Right before 0.5 or 0.50.
That goes up to 50?
It's 0.4, so right under it. Or 0.40, sorry.
So something like that? Is that right?
No, I messed up. I was in the other one. 0 is 0.30.
So it goes to right there. Don't get rid of that. Is that right? Then what?
It's 0.40.
Point four.
So the next one goes up to there, right?
Yes.
Then what?
Point two.
Then what?
0.06. Yeah.
Then what?
0.04.
They didn't ask you to do this, but on the test I might. Any of these number of toppings unusual? It's unusual to get asked to put how many toppings on?
4.
Four.
Remember, unusual means anything less than 5%. What's this curve look like? Describe it for me.
Skewed to the left.
Skew to the
Right.
right. Skew to the right. If it's skewed to the right, then that means the probability should be less than 0.5, because if we're looking right down the middle here somewhere where we're separating it, it's got as much on this side as it does on that side, so on and so on. All right, test next time.